Today we're doing chapter 25, paired sample and blocks. The data below are the ages of a random sample of 14 couples who obtained their marriage licenses in Montgomery County, Maryland in 2002. So we have our 14 couples, husband's age, wife's age. You want to answer the question, do husbands tend to be older than wives? And we want to know, is a two-sample test appropriate? So no, the two samples are not independent. The wives are not chosen independently of their husbands. So they're linked here. So the first thing we want to do is fill in the last column of the table by subtracting the wife's age from the husband's age. And if you want, you can put all the husband's age in list 1, the wife's age in list 2, and then do L1 minus L2 in list 3 to get the difference in ages. And here are the differences in ages. So we're going to conduct a significance test of whether the mean of the population of age differences exceeds 0, suggesting that the husband tends to be older than the wife. So what type of test is appropriate? We would do a match pairs t-test. So you need to state the name of the test that you're doing, and this would be a match pairs t-test. And we'd use a one sample t-test for the mean of differences. Our parameter mu is the mean age difference between husbands and their wives, so husband minus wife in Montgomery County in 2002. Our null hypothesis is mu equals 0. Our alternative hypothesis is mu is greater than 0. Our assumptions, paired data assumption. The data are paired because they are from members of the same married couple. And it was stated that it's a random sample. And 14 couples is less than 10% of all married couples in Montgomery County. Or you could state the population of married couples in Montgomery County is greater than 140. Sketch a graph of the data and describe its shape. So I used a normal probability plot. And here our normal probability plot is fairly straight. So we can assume the population of the differences distribution is approximately normal. So we're going to use a paired t-test. So we're going to use a paired t-test. We already stated the name of the test. So now what we need to do is we need to write the formula down for our test. So our T would be the mean differences minus mu all over the standard deviation of the differences divided by the number in our sample. So our T, what we would do is we'd run a test and it give us all this information. You still have to write down the formula and plug everything in, but you can use the test to find it. So you go to stat and test, choose number 2 t-test. We're going to use the data that we put in, the differences in ages. Our mu is 0. Our data is in list 1. The frequency is 1, greater than. And when it's greater than, our test statistic is 2.887. Our p-value, mean, standard deviation, and the number we have. So our mean would be 3.929 minus 0. All over our standard deviation is 5.091 divided by 14. This would give us 2.887. Also write down your p-value, which is 0.0064. So here we have our test statistic, but they also talk about our p-value here. Since they did not give us a significance value, we're going to default to alpha equals 0.05. So here our p-value is less than alpha because 0.0064 is less than 0.05. So I would reject my null hypothesis. So my conclusion would be I reject the null hypothesis because the p-value is less than the significance level of 0.05. You would also state that 0.0064 is less than 0.05. There's strong evidence that for married couples in Montgomery County, husbands tend to be older than wives. Next, we're going to do a 95% confidence interval for matched pairs. So this is a matched pairs T interval. Okay. When we do this, we do need to write down the formula. So it's the mean difference plus or minus T star n minus 1 times the square root of the standard deviation in differences squared divided by n. And you want to write this down and plug everything in, but you can also use your calculator. So it's a T interval. We're using our data. This is a confidence level of 0.95. Okay. And when we go ahead and we plug that in, we get our interval, but you want to plug in the information. So X bar would be 3.928. And then T star you'd find on your table, or you would use your calculator for inverse T because you have your degrees of freedom, which is 13 because it's n minus 1. And you would get 2.16. So this would be plus or minus 2.16 times the square root of, my standard deviation is 5.091 squared all over 14. So my interval, which they list right here, is 0.98916 to 6.868. Next, you need to come up with a conclusion from it. You would say, I am 95% confident that in Montgomery County, husbands on average between 0.99 and 6.87 years older than their wives. So now I want you to go through questions 1 through 5 and determine whether it's a matched pairs or a two-sample t-test based on the scenario. So pause the video now and do these 5 problems on your own. So number 1, to test the wear characteristics of two tire brands, A and B. Brand A is mounted on 50 cars, brand B is mounted on 50 other cars. Here it would be a two-sample t-test because the tires are mounted on different cars. Number 2, to test the wear characteristics of two tire brands, A and B. One brand A tire is mounted on one side in the rear, while a brand B tire is mounted on the other side. Which side gets which brand is determined by a coin toss. The same procedure is used on the front. This would be a matched pairs t-test because both tires are used simultaneously on the same card. To test the effect of background music on productivity, factory workers are observed. For 1 month, they had no background music. For another month, they had background music. This would be a matched pairs t-test because the same workers received both treatments. Number 4, a random sample of 10 workers in plant A are compared to a random sample of 10 workers in plant B in terms of productivity. This would be a two-sample t-test because the workers work at different plants. And number 5, a new weight reducing diet was tried on 10 women. The weight of each woman was measured before the diet and again after 10 weeks on the diet. This would be a matched pairs t-test because the same women were used for both samples.